What's up guys, welcome back to the channel, and today I will be doing the Thevenin Theorem. So I'll be showing you guys the theorem. That is one of the broad topics that is coming on the electrical paper for CAPE. Yeah, I have exams soon, so pray for me. But that is one of the topics that is coming on the electrical paper, and I'm going to do that in this video. If you guys don't know what that is, would like to learn what that is, then just stay for the video. Please like, comment, share and subscribe. Throughout the video I go probably hear some little puppy, because my dog just had just have some puppy and them make be nice, cause them probably hungry or something, I don't know. But yeah, please like, comment, share. Don't forget to subscribe. Go to my other video, them like them, share them, subscribe, tell your auntie, brother, sister, tell everybody. Alright, no bag along talking, we can get another video. The Thevenin theorem states it is possible to simplify any linear circuit, no matter how complex it is, to an equivalent circuit with just a single voltage source and a series resistance connected to a load. And if this definition is not clear, don't worry, I will be demonstrating. For demonstration, I have a book and a pencil, and I also have the calculator over here for the calculations when you read further in this video. So what I'm going to do now, I'm going to go ahead and I'm going to draw a simple but complex circuit. So this right here is represented as the voltage source. So Vs, S is a subscript. So now we need resistor. I'm going to add resistors, and resistors can be represented as the zigzags, but I cannot draw the zigzags properly, so I'm going to represent them as the rectangle. And we need another, let's say we have another resistor right here, and we have another resistor in parallel. And we have a resistor, a load resistor. So we have a load off the end right here. Right, so let's go ahead and label it. So we have R1, R2, R3, and this right here is the load resistor, so this would be represented by RL. And what the Thevenin law is basically saying is that we could represent all this with just one voltage source, and all these resistors, or the resistance, could be one resistor. So when we have the Thevenin theorem, the voltage source would now become the V Thevenin. Right, so still have your source, but that is now represented as V Thevenin. And we will come right here, and also all these resistors or resistance is now represented by R Thevenin. So we would have the large V, and the TH would be subscripts, as well as the R, large R, TH is the subscript. Oh my god, hear them. Okay, so and then we would also put back our load as the same thing. So our resistor load right here. Yes. So this is what it would look like. Now we're going to add some values to this. So we're just gonna add some random values. Vs, let's say Vs is 30 volts. Let's say R1 is 10 ohms. We all know that resistance is measured in ohms. so that is why I have ohms right here. And this one, R2, let's say R2 is 8 ohms, and let's say R3 is 2 ohms, right? And we still have RL. So first we're going to find the voltage Thevenin. So step 1 in the calculation for the Thevenin voltage, you're first going to remove the load. So remove the load resistor. So I'm going to redraw this circuit and show you what I mean. So we still have Vs, we still have the source voltage, and we have our resistors, and in the middle right here we have another resistor. So now removing our load, so we're going to have it right here, this right here, but out here. So let's just say we break our circuit and remove the load. That is that. Now since we have done this, we are now up past step 1 in our calculation for the Thevenin voltage. Now if you notice, we have a broken circuit. Our circuit is broken, so obviously because it is broken, no current is going in here, which leads us to having no voltage in this area. So basically, because there are no voltage drop across here, across this part, because it is broken, the voltage across here and here would be the same, they will be equal. So now that we have that done, we need to use the voltage divider principle, because as you can see, the voltage is dividing. You have voltage here and voltage here. Remind you that we have series circuit and parallel circuit, and in the parallel circuit the voltage is constant and the current is shared, right? Voltage divider principle, as I was saying before, the voltage is here, it's divided. So we need our formula, which is VT8. So this is the formula for voltage Thevenin, or Thevenin voltage, is equal to Vs, which is this right here, the voltage source, over R1 plus R2, and all this is times R2. So we could put all this in one bracket just to show that we are going to be working this out first. So we can go over here and substitute. So still have a V, your Thevenin voltage, and we're going to be substituting. So Vs, which is 30, over R1, which is 10 plus R2 is 8, and all this times R2 again, which is 8. Okay, so we can go ahead and work this out now. 10 plus 8 is 18, and we're going to say 30 divided by 18 is equal to this number right here, and we can just go ahead and round it off and have 1.67. So it's VTH equal to 1.67 times 8, and we can go ahead and times 8. This is equal to, so V Thevenin voltage is now equal to 13.33 volts. Simple as that. That is how you calculate your voltage, Thevenin or Thevenin voltage. Remember, step 1 is to remove your load, and step 2, ensure that you go by the voltage divider principle, which is this formula right here. Now moving on to calculating our Thevenin resistor or Thevenin resistance. Now, when it comes to calculating the Thevenin resistor, the first rule is to remove voltage source. I write so crappy, forgive me. Alright, so we are going to remove the voltage source. So I'm going to again redraw the circuit with all the resistors. So we still have the load on this one, only for the, when we're calculating the voltage Thevenin, we remove the source, the load. But for this one, we have the load on this one. So how do we remove the voltage source? So this is the voltage source. How do we remove it? So we are going to basically break the circuit or shorten the circuit. So what we're going to do, the closest part, like where the voltage source is, we're going to break there. So as you can see, it's right here between here. So we want to just break it like this, just like that, you can see. So just ignore this part where the voltage source is. So we are looking beyond this line, and beyond this line we can see that we have R1, R2 and R3 and the load resistor or the load resistance. Now what we're going to do, we need to find our Thevenin, as I said before. So basically we need to find the total of this. So we're going to draw this in a simpler version so that you can see properly. Now this and this is in parallel, as you can see. Now series, remember I don't know if I was telling you before, so series is where you have one, where you basically have one complete path for the current to travel, whilst parallel is where you have different paths where the current could travel. So a current could go here and here and here, and it could also go here. Now as you can see, current can come through here, and it can go here, and it can go here if it wants. So what we're going to do, we're just going to construct this in a simpler circuit. So we have R1. We have R1. Sorry, had to pause that. My battery was about to die. We have, as I was saying, this and this is in parallel, so let's place them in parallel. R1, which is right here, and we can have R2 right here, and R3 right there, and we still have our load. You don't have to pay any mind to your load, because we're not going to really use the load right now, because the load is like a bulb or just something that you're going to use to basically test the circuit. So what we're focusing on right now is R1, R2 and R3. So our values were 2 ohms, R1 was 10 ohms and R2 was 8. And we're going to have it right here, just like that, 10 ohms, whilst R2 is 8 and R3 is 2. Now we need to have our formula for the Thevenin voltage, or sorry, the Thevenin resistance, which is going to be R Thevenin right here is equal to this plus this plus this, but there's a rule. You cannot say R1 plus R2 plus R3 because R1 and R2 is in parallel. So right now we have two resistors in parallel, so we can use the formula for the two resistors in parallel, which is R1 times R2 over R1 plus R2, and all of this is going to be times by R3. So yes, normally there are different formulas for the resistors in parallel to find the total resistance in parallel. You have the other one that goes, this is for more than two resistors. So you have 1 over R1 plus 1 over R2 plus 1 over R3, etc. That is the one for like the circuits with more than 3 resistors, but this is the simple way to do it for circuits that has only 2 resistors in parallel. So we can go ahead and substitute. So R1 is 10, so 10 times R2, which is 8, over R1 again, which is 10 plus 8, and all this is going to be times by 2. Alright, so 10 times 8 is 80 over 18. All this again is going to times 2. So now we need to work out 80 divided by 18, and this is what we got. And again, we can go ahead and round it off, so we have 4.44 times 2. So all this, and we're going to times it by 2, which is 8 by 8.89 ohms. And as I said, you can round it off to 2 decimal places. So this now, 8.89 would be our R Thevenin. So the last step in doing this is that you're going to draw your simplified circuit. So we're going to draw our circuit with V Thevenin and R Thevenin. So let's do it right here. So V Thevenin is 13.33 volts. Don't forget your what you call them, your units. Don't forget the volts, the ohms, and whatever you're working with. So this is VTH, and we have R Thevenin right here, RTH, which is 8.89 ohms. And we have our load. You don't have to take off your load. You need your load because that is what's going to test if the circuit works just the same as this one. And we have our L. So basically this is the Thevenin theorem. Why can I not pronounce that word? This is the Thevenin theorem. So what it is saying is that this circuit round here is basically equivalent to this, same amount, same function, just different format. It's the same, It's just different format, different it's the same values but in a different way. You get what that means. Is it for the Thevenin theorem. Yeah, I cannot pronounce that word. I do not know why, but that is it for the Thevenin theorem. And I want to say thank you for watching. Please like, comment, share and subscribe. If there is anything else that you'd like me to do, please type that in the comment section below. Remember that I am still learning, so when I grasp a concept I take it to you guys. What else am I supposed to say? Yeah, I guess that is it. Yeah, stay blessed, give bless, my love.